In this session, we will continue with the series of videos that we are doing on homogeneous differential equation. For the given differential equation, we will try to show that it is a homogeneous differential equation and we will try to solve the homogeneous differential equation. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. The question is, show that the differential equation y dy plus x log of y by x dy minus 2x dy is equals to 0 is homogeneous and solve it. To show that the given differential equation is a homogeneous differential equation, first we need to show that the function f of x comma y is a homogeneous differential equation. Therefore, we need to express the differential equation dy by dx in the form of the given function f of x comma y. First, show that this function is a homogeneous function. If this function is a homogeneous function, we can conclude that the given differential equation is a homogeneous differential equation. So let us try to simplify this one. Let us try to simplify the given differential equation in the form of dy by dx is equals to f of x comma y. So let us try to rewrite this differential equation. So if you try to observe over here, you have dy and dy over here. So I will try to group this dy values together. So let me rewrite the differential equation. Y dx I will retain as it is. I will try to group these two values. We have x log of y by x minus 2x. So just group that one, taking dy as common outside. So if I take dy common, then we will be left out with x log of y by x minus 2x is equals to 0. Or further, let us try to send this y dx on the other side, retaining this value x log of y by x minus 2x times of dy on the left hand side, and this value on the right hand side will become negative minus y dx. Or dy as it is, cross multiply the dx on the other side becomes divided by dx is equals to, you have minus y on this side, cross multiply this value on the other side becomes divided by x log of y by x minus 2 times of x. So if you try to observe over here, in the denominator x is common. So let me take x common outside. I will be left out with log of y by x minus 2. I can just take this x in the numerator. Can I write this as minus, group this one, y by x it becomes, it is whole divided by the denominator log of y by x minus of 2. So we have expressed this dy by dx in the form of this f of x comma y. So this right hand side value is nothing but f of x comma y. So here we have f of x comma y to be equals to minus y by x, it is whole divided by log of y by x minus of 2. Now if you want to show this given function is a homogeneous function, we have to replace the value of x by lambda of x, y by lambda of y, and express it in the form of lambda power of 0 into f of x comma y. Then we can say that f of x comma y, this function f of x comma y is a homogeneous function of degree 0. So let us try to express in this form. Put the value of x to be equals to lambda of x and the value of y to be equals to lambda of y. So we get f of lambda x comma lambda y. So we have here y to be equals to lambda of y divided by x to be equals to lambda of x. It is whole divided by, in the denominator we have log of y to be equals to lambda of y, x to be equals to lambda of x minus of 2. So we can cancel out this lambda and lambda, this lambda and lambda will cancel out. So what will be left out now? Minus y by x whole divided by, in the denominator we are left out with log of y by x minus of 2. Now you check this one, is it not f of x comma y? So therefore this is nothing but the function f of x comma y. Can I rewrite this as lambda power of 0 into f of x comma y, because lambda power of 0 is just 1 there. So if we are able to express f of lambda x comma lambda y as lambda power of 0 into f of x comma y, we can say that this f of x comma y is a homogeneous function, of degree 0, because the power of lambda is 0 here, therefore degree is 0. So if the function is a homogeneous function, we can conclude that therefore the differential equation, or I can write in short DE, the differential equation is a homogeneous differential equation, that is DE. So what is the differential equation given? The differential equation that we have is dy by dx is equals to minus y by x whole divided by log of y by x minus of 2. Let us take this differential equation as equation number 1. Now how to solve this differential equation? So we have to put the value of y to be equals to v times of x. Let us try to differentiate this one with respect to x. Differentiate with respect to x. So we get dy by dx is equals to, on the right hand side vx is a product, therefore we will try to use the product rule. V as it is, differentiation of x is 1 plus x as it is, differentiation of v with respect to x will be dv by dx. That can be rewritten as v plus x into dv by dx. You can just substitute this back in equation number 1. So equation 1 can be rewritten as dy by dx is v plus x into dv by dx is equals to, right hand side we have minus y value is vx divided by x whole divided by log of y value is vx divided by x minus of 2. We see that this x and x will cancel out, this x and x will cancel out. So we are left out with minus of v divided by log of v minus of 2. We can rewrite this as v. You can just multiply this minus in the denominator. So this minus into minus will become plus 2. So first I will write the positive value. If you multiply this minus over here, it becomes minus log of v. On the left hand side, the expression will remain the same. Now send this plus v on the other side. This plus v, when it comes on the other side, becomes minus of v, and here you are left out with x into dv by dx. So let us take the LCM over here. It is 2 minus log of v. So this is v minus, cross multiply this, it is v times of, you will be getting 2 minus log of v. Or further, if you try to simplify this one, it is v minus, multiply this v inside, it is 2 times of v. So minus of minus will become plus, multiply this v inside, it becomes v times of log of v. It is whole divided by, in the denominator you have 2 minus log of v. So v minus 2v will be minus of v plus v times of log of v divided by, we have 2 minus log of v. We can further simplify this as, first I will write the positive value v log of v, then the negative value minus of v whole divided by 2 minus log of v. Now let us try to separate the variables. We'll take this on the other side. So here I will try to retain this dv value and send this v value on the other side. So we have 2 minus log of v, it's whole divided by v log of v minus of v times of dv is equals to, cross multiply the dx and x, it becomes dx by x. Since it is in the variable separable form, we can integrate on both the sides. So integral of 2 minus log of v divided by v log of v minus of v times of dv is equals to, it is integral of dx by x. We can neither integrate this integral directly, nor we can use the substitution method to integrate this one. So we need to simplify both the numerator as well as the denominator. So let us try to simplify it. So in the denominator, let me take that minus of v outside. So in that case, because minus v is gone outside, you are left out with minus of log v there, and because minus v is taken outside, its plus 1 is left out. Now in the numerator, in the denominator, it is in the form of 1 minus of log v. So 1, since you have 1 over here, try to get 1 value over here. So can I write this as 2 as 1 plus 1, 1 plus 1, and then we have minus of log of v. So times of dv is equals to, here integral of dx by x will be log of mod x, plus, because this is in terms of log, we will try to add the constant of integration also in terms of log. Now we will try to group this 1 plus log of v over here, and in the denominator also it is in the form of 1 minus log of v. We will try to split this term, and this 1 is divided by the whole of the denominator. So we can write it as 1 divided by minus v times of, I will first write the positive value 1, then minus of log of v, then times of dv. Like this 1 minus log of v I will try to separate, plus again apply the integral of 1 minus log of v divided by the entire denominator, that is minus v into, first I will write 1, then log of v, 1 minus log of v times of dv is equals to, this is log of mod x as it is, plus log of c. We can observe that 1 minus log v, 1 minus log v will cancel out. Just close bracket over here. So we can rewrite this as integral of 1 by minus v times of 1 minus log of v times of dv. Over here minus sign you can take outside, minus into plus will become minus, integral of 1 by v into dv, that is nothing but log of mod x plus log of c. So let us use the substitution over here. So put the value of 1 minus log of v to be equals to, say, some t, and we will try to differentiate this one with respect to v, differentiate with respect to v. So if we try to differentiate this with respect to v, we get derivative on the constant is 0, log of v will be 1 by v, that is equals to, differentiation of t with respect to v will be dt by dv. Since we have minus 1 by v over here, so retain that minus 1 by v as it is, send this dv, because we have dv over here, send that dv on the other side, will be equals to what? Will be equals to dt. Now substitute this 1 minus log of v and minus 1 by v dv in the given integral. We get integral of this minus 1 by v into dv is what? Its value is dt, divided by 1 minus log v, this 1 minus log v value is t, minus this integral of 1 by v dv is nothing but log of mod v, is equals to, we have log of mod x plus log of c. Further, this integral of dt by t will be nothing but log of mod t, minus we have log of mod v is equals to, now this is in the form of log m plus log n, which can be written it in the form of log m into n. So therefore we can write it as log of mod cx. On the left hand side, since it is in the form of log m minus log n, which can be written in the form of log m by n, that is t by v, is equals to, it is log of mod cx. Or if we try to eliminate the value of log, we are left out with t by v is equals to cx, or t will be equals to cvx. Now let us try to see what is the value of t we have. The value of t that we have taken is 1 minus log of v. So you can put the value of t to be 1 minus log of v. But the value of t will be equals to 1 minus log of v. What about v value? Initially we have taken the value of y to be equals to vx. From here we can get the value of v. So we have y is equals to vx. So just cross multiply that x on the other side, will be getting v is equals to, cross multiply that x on the other side, we get y by x. Therefore we can just substitute this value of t as well as v. So here t value is what? T value is 1 minus log of v is equals to c into v value is y by x times of what? Times of x. But we see that this x and x will cancel out. But still we have v over here, v value is y by x. 1 minus log of v value is y by x is equals to c times of y. Or you can rewrite this as cy to be equals to 1 minus log of y by x. That's the required solution. That's all I have for today. If you like my video, please subscribe to my channel. Thank you.